Hello dear student, today in this video we are going to discuss an important question of CSIRNET December 2015, right? So what is the question? The question was about continuity of a function. The question was that f be function from 0 on to r be continuous, and suppose that this condition is satisfied. Mod of f minus phi will be less equal to mod of cos x minus mod of cos phi. Mod of cos x minus all mod for x belongs to 0 on. Okay, so there are some option. Okay, the first option was f is discontinuous at least one point. Second option was f is continuous everywhere in on 0 on but uniform continuous on 0 on. And third option was f is uniform continuous on 0 on. And fourth option was limit x to 0 f is exist. Okay, so देखते हैं कौन ट्रू है. ओके, पहले तो सॉल्व करें इसको. तो क्या दिया है इसको हम लिखते हैं पहले. mod f x minus fy, this will be less than mod cos x minus cos y. Okay, now we know the formula cos c minus cos d, so we apply solution. Applying there, this formula 2 sin x plus 2 sin c plus d by 2 into sin d minus c by 2, right? Minus means y minus x by upon 2. Okay, now this can be mod of ab. This can write mod of 2 is 2 positive, and mod of sin x plus mod of ab is mod of a into mod b, right? Mod it is a, it is b, mod of b will be mod a into mod b. So this will be mod of y minus x upon 2, right? Now we all know that mod of sin x is less equal to 1 always, right? Mod of sin x is always less equal to 1 for any x belongs to r. Okay, here x belongs to open 0 on, so this also hold, so we can write this 2, and this is x is a real number, y is a real number, x plus y by 2 is a real number, so this is also less equal to 1, this mod, and there is left mod sin y minus x by 2, right? Now there is one more result. Mod of sin x would be always less equal to mod x for x belongs to r. Okay, this is one more result. So if we apply here, we get mod of sin y minus x by 2 will be less equal to mod of y minus x by 2. Okay, 2 to or so mod of y minus x will be same as mod of x minus y, mod of same of x minus y, right? So we start from this mod of x minus y, we get less equal to mod of x minus y. Okay, so what we have started? We started with mod f a function from 0 on 1 with given condition, and we get mod f minus fy. This would be less than mod of x minus y. Okay, for x comma y belongs to domain 0. Now if I choose if I choose x comma y, if I choose x comma y belongs to 0 on, okay, right, with mod x minus y less delta, then this implies mod fs minus fy would be less than this one less delta, so this become less delta, right? Here less than equal to less than, so this become ultimate less than delta. Now I'm choosing delta equal to epsilon, so we get mod f minus y less than epsilon. Okay, so if we have mod x minus y less delta, if mod f minus y less delta, we get the images f minus y less than epsilon. Here is 0, here is 1, there is x, y. If distance between 2 point less delta of the function, their images also less than epsilon. If distance between 2 point less than delta, then distance between the images will be less than epsilon. This is a condition of uniform coordinates, right? So we can say that f is UC, uniform coordinates on 0. We all know that if a function is uniform coordinates, then it directly implies it is continuous. Okay, so f cannot have any point of discontinuity on 0. Okay, so f cannot have any point of discontinuity on 0. Okay, now I'm coming from the option. So we get f is f from 0 to r is UC, uniform coordinates, and since it is UC, it is continuous also, because every uniform function is continuous. If function is uniform coordinates, then it's continuous also, so it becomes continuous also. Okay, now there are options. First option is if it is discontinuous at least 1 point in 0, it's not possible, because if f is, we know that we get the f is continuous, so it cannot be discontinuous. So option 1 is incorrect. Option 1 is incorrect, right? First option was f is discontinuous at least 1 point in 0. It is incorrect because f is continuous. Second was f is continuous everywhere but not uniform coordinates. F is continuous everywhere but not uniform coordinates. It is wrong because we get f is uniform coordinates. Okay, so option 2 is incorrect also. Now option 3. Option 3 is given that f is uniform coordinates. So it is right. I proved that f is uniform coordinates. Okay, so option 3 is right. Option 4, limit x to 0. Option 4 is limit x to 0 fx exists. Okay, limit x to 0 fx exists. Now what about option 4? We know that result, if function f from open AB or AB are real number is uniform coordinates UC open AB. Okay, if and only in point, limit of in point should exist. If you go toward x, so we have to go toward like this. Okay, because in this portion x f is not defined. F is defined only in this interval, so we have to take this limit, right limit, and for in case of b we have to take left limit. Okay, then there is no right limit exists, because then we have in domain open AB. Okay, so if function f from AB to R is uniform coordinates on AB, if limit extends to a plus, right limit extends to a plus fx and limit extends to b minus. Okay, you have to go toward like this, b minus fx, both exist. This both limit should exist. Okay, finitely means this limit should be finite and this limit should be finite. Then the function is uniform coordinates. It is real and it is not real. In every book we will get. In every book of real analysis, you will get this result. If a function f from AB to R is uniform coordinates, then limit extends to a plus fx would exist, and limit to b minus would exist. And conversely, limit to a plus fx and limit to b minus fx would exist, then the function will become uniform coordinates. Since if I have proved that if a function is continuous uniform coordinates on open 0, so from this result we can easily say that limit x to 0 plus fx exists. Okay, and then option 4. See, option 4 was limit x to 0 f exists. Limit x to 0 fx exists. Okay, so this option will be true. So option 4 will be true. In this case, limit x to 0, in this case there is no left limit. Okay, and also no function value if of exists, because the domain is open AB. So in this case, limit x to 0 plus this fx equal, this is nothing but limit x to 0. Okay, we know that this limit exists. Okay, this limit exists because f is uniform coordinates, so this limit will exist. And option 4 is this. Okay, so option 4 is correct. So correct option are option 3 and 4. Okay, in this question it was the condition f is minus f5 mod f is minus f5 would less than mod cos x minus cos y, right, whenever for all x5 belongs to open 0. Okay, this is the condition. And where f is a function from 0 to r. Okay, is continuous function 0 to r a function. Okay, this is the condition. Okay, now if we can make this cosine slightly change. Okay, in place of cos you can replace sine, then also the similar result. Like I am saying that if the cosine was like this, mod fx minus fi less than mod of sine x minus sine y for xy belongs to open 0. Okay, while if a function from same 0 on to r, then you get the similar result. For this question, the result you get, you also get the similar result for like this. Okay, because from here you can write sin minus sin d, this is like cos x plus y by 2. This question not came in CSIRNET with sin, with cos came in CSIRNET, but this maybe can, because they are similar question. So this can be 2 cos a plus b by 2 and sin a minus b by 2. This can be, this will be less equal to 2 into mod cos, mod sin is mod cos is equal to 1, so this will be 1. So mod sin x minus y by 2. Okay, and mod sin will be less than mod x, so this can be write 2 mod x minus y by 2. Okay, so we get mod x minus y by 2. So similarly, SPUS I get mod f x minus y will be less than equal to mod of x minus y. Okay, and from here we can easily conclude that f is uniformness. Okay, we get mod f x minus fy will be less than mod x minus y. Okay, for x belongs to open 0. Okay, open 0. Okay, so from there we can easily conclude that if you see uniformness on open 0 and hence continuous. If a uniform function is continuous, if a function is uniformness on domain open AB or close AB, say, or interval I, then it automatically continuous on that interval. Okay, so if the question was in place of cos there is sine, in place of cos there is sine, in place of cos y there is sine y. Okay, then this result also hold. Okay, so this can be a question in future CSIRNET. Okay, so I think I have cleared the all doubt regarding the question. Okay, if you have any doubt you can ask in the comment section. Okay, so thank you.